Okay, so for this video, I want to go through some past exam questions on from the Leaving Cert Ordinary level on sequences and series. That's your patterns and things like that. So at Leaving Cert Ordinary level, you can get the sequences and series formulas on page 22 of the formula book. Okay, and now at ordinary level, you only have to know these top ones here. So there's only arithmetic and quadratic on it. So you just need to know these top ones. You don't need to worry about the geometric series. So arithmetic series, we always have A is the first term, D is the common difference, and Tn is the nth term, and Sn is the sum of the first. So we have a sequence with general term is A plus n minus 1d, and a series with general term is this one here, Sn. So just make sure you know that you can find them on page 22. Just check the index. Okay, so at ordinary level, we just need arithmetic and quadratic. So a sequence is just a list of numbers like you see here on the right. Okay, so you can see that it goes plus 3 every time. Okay, so that has what's called a common difference. Okay, that's what's down here. D is the common difference. So we can see very clearly here, the first term, A, is equal to 2, and the common difference, D, is equal to 3. Okay, so we'd sub that into our formula here to get the answers. Okay, the only difference in a series is that they are added together. Again, we're going plus 3 every time. Okay, it's the same numbers, and so our common difference is 3 still as well. It's the same sequence, it's just in series form. So again, A is 2, D is 3, and we'd sub that stuff in over here. Okay, the other one that you need to know is a quadratic sequence. Okay, now these are not in the formula book. I don't know why, but they're just like quadratic functions. So it's an squared, so something squared, plus bn, so something n plus c. So a number, it could be something like 3n squared plus 2n plus 4. That's just an example. Okay, it's just like your quadratic function, you know, x squared plus 4x plus 6 or something like that. Okay, so here's an example of a quadratic sequence here. Okay, so we can see if there's plus 4 here, we have a plus 8 here, a plus 12 here. So you can see immediately that that's not the same as the linear ones. But if we go to the second difference, we have this thing called a second difference. Okay, so when you put them all in line, we have this plus 4 between each. And we see here that A is half the second difference. So we'd have A is 4 is the second difference divided by 2. So A would be 2. So it would be, this function would be 2n squared plus and a few other things here. Okay, so to work that out, you would need to sub in for n equals 1 and n equals 2, and then use simultaneous equations to solve. So just for an example here, this would be 2 by 1 squared, so this is subbing in for n equals 1, plus b times 1 plus c is equal to 3, because that's our first term, that's our t1. And then we would also put in for n equals 2, so 2 squared plus b times 2 plus c equals 7. That's T2. And then we work these out as simultaneous equations and solve them. But anyway, let's get right into the exam questions. That's just a revision on linear and quadratic sequences. Okay, right. So first one we've got here is from 2024. And these are generally paper 1 questions. This one's question 8b. So we see Ellie is taken up running. So she's running 6 kilometers and runs 1.5 more each week. So that means here we've just got plus 1.5 every time. So 6, 7.5, got 9, 10.5, 12, and 13.5 as our distances here. That's all we need to do. Okay, now you're saying if Ellie continued with this pattern, find the distance she'd run in week 100. So you're going to have a lot. So we're going to look, we're not just going to write out 100 numbers. We want to look at our Tn here. So this time what we're looking for is term 100. Okay, so we'll sub in n equals 100. Okay, we know our first term is 6 and our common difference is 1.5. So we can just sub all of these things in. So term 100 is A, so 6 plus 100 minus 1 times the common difference, which is 1.5. So 6 plus 99 by 1.5. And that gives us 154.5 kilometers. Okay, so she's running a lot in that week. And that links down to the next question here, where it says explain why she cannot continue this pattern indefinitely. So take another 100 kilometers. You can assume another 100 weeks, that'll be another 150 kilometers. She's not going to run 300 kilometers in a week. So you can't run an infinite amount. Okay, there's no way that she can keep on running forever. Like, think about it when she reaches week 200, or well, week 2000 maybe, it'll be really big. So she can't run an infinite amount. Okay. Okay, on to part 4 now. We are told Sn is the total distance she's ran after n weeks, where n is a natural number, so n is a whole number. So we need to use our Sn formula down here. So Sn is n over 2, 2a plus n minus 1 times the difference. Okay, and we have everything we need. A is 6 and d is 1.5, which we know from the last time. So we've just got to sub all these in. So n over 2, 2a, so 2 by 6, plus n minus 1 times 1.5. Okay, so you just sub these in, multiply them out. N over 2, 12 plus 1.5n minus 1.5. And just simplify it out by grouping your like terms. That's your 12 and your minus 1.5. So you have got 10.5 plus 1.5n. Okay, you could multiply this out, but this should be enough for this one. Okay, so write Sn in terms of n. So that means in terms of n means keep an n in your answer. Okay, and just to the last bit, using your answer to part B4, or otherwise find the total distance run by Ellie after 10 weeks. Okay, so it says find S10, so we can do S10 equals, we sub in 10 for n, so 10 over 2, 10.5 plus 1.5 by 10. Okay, so 10 over 2 is 5, and then 10.5 plus 15. Okay, so we just stick that into a calculator. 5 by 10 is 127.5. Okay, 127.5 kilometers. So she's run a right bit after those hours. Okay. Okay, so here's the whole question done. It's just part B of question 8, so you can see all of the answers there if you want to check them. Okay, we'll go on to the next one now. Okay, so next is from 2022 here, again paper 1, and this is a short question, so 30 marks. So theoretically this should take you maximum 15 minutes in an exam. Okay, so you're told to find the nth term of an arithmetic sequence is given the following. So Tn is this, find the volume of T1. Okay, so that just means sub in 1 for n. Okay, so minus 254 plus 1 minus 1 times 4. Okay, and this becomes a 0, so they will cancel out. So term 1 is just minus 254. Okay, so find the value of the common difference for this sequence, that is T2 minus T1. So we need to find T2 first, so minus 254 plus 2 minus 1 times 4. Okay, so 2 minus 1 is 1, so it's minus 254 plus 4, which is minus 250. Okay, so what's the difference between minus 254 minus 250? Okay, the difference is just 4. Okay, so that's the difference. And if you knew your formula well, you would know that this 4, okay, so remember our form is a plus n minus 1 d, so we'd have known that that 4 should have been the difference anyway. Okay, moving on down now to just the last part. No, there's a part on the right as well. Third part, part B. So find the smallest value of n for which this is greater than 0. Okay, so let's multiply out our brackets here. So minus 254 will stay as it is, and we need to multiply it. So n times 4 is 4n, and minus 1 times 4 is minus 4. It's greater than 0. So what you're doing is you're setting up a linear inequality here. So minus 254 minus 4 will give you minus 258 plus 4n is greater than 0. Okay, and now you want to move this minus 258 over to the other side. So we're going to plus 258 to each side. And you're left with 4n is greater than 258. And then for your last step, you're just going to divide by 4 on each side. So 258 divided by 4 is 64.5. So n is greater than 64.5. Okay, now you see this n is an element of n, so n is a natural number. So we need to pick the first natural number that's bigger than 64.5, so that's going to be 65. Okay, you need to be careful when that comes up in an exam to make sure that even if you've done the right work, you're still getting the right answer, because you'll lose a mark if you don't have it right here. Okay, going on up now to part C, part C. Okay, so you're given the sum of the first n terms. It's given by this formula up here, and solve the following equation. Okay, so what you're going to need to do here is multiply this out. So keep your n over 2 as it is for now, and so it's going to be minus 508 when you multiply these two, plus 4n minus 4 equals 0. Okay, simplify inside your bracket. So minus 5, so it'll be minus 512 plus 4n. Now, in order to solve this, we're going to have to multiply out this bracket. Okay, so it'll be minus 512n over 2 plus 4n squared over 2. Now, to get rid of these 2's, these can cancel out. So 512 over 2 will be 256. So we'll have 256n plus, now this 4n squared over 2 will be 2n squared equals 0. Okay, now if you want to set this up in a way that might be familiar to you, we've got an n squared and an n. So, clicked on the news there. 2n squared plus 256n equals 0. That might be a bit more familiar, and now what we can do is we can factorize this. Okay, so we can take out the factors here, factors. Okay, so 2n is in common here, so 2n times n gives you 2n squared, and plus half of 256 would be 128. Okay, equals 0. So 2 by 128, better double check that. Yeah, it's 256. So we've got 2n equals 0, meaning n equals 0. You've got n plus 128 equals 0, which means n is minus 128. Oh, I have missed out on a minus here. So you see this 256, there should be a minus there, should be a minus there, so that should be a minus. So that should be a minus, and that should be a plus. So n is 128. Okay, 128, because you see in the question up here, it says n is not equal to 0. So that means that this is not our answer. So this one is our answer. Okay, so sorry about missing out the minus bit there, but yeah, that's how you do that one. So you can see from this question, quite a bit to do in it actually. First two parts are nice and easy. Okay, and then you've got to solve a linear equation there, and you've got to solve a quadratic equation up there. Okay, so it's testing lots of different parts of your knowledge in these questions. All right, so take a look at that one, and we'll move on to the next one then. Okay, so we'll continue our journey back in time now, and we're back to 2021. Okay, so you're told that the first three terms of an arithmetic sequence are minus 5, k, and 1. Okay, so find k and else or otherwise show the common difference is 3. Okay, so this means that this and this, so the difference between these is going to be the same. So that means that minus 5, k, and 1. K is going to be halfway between each of these, okay, because we've got a common difference. Okay, so if it says it in the question even, so plus 3 and plus 3. Okay, so each time you're going to have minus 5 is going to plus 3 will give you minus 2. So that means minus 5, minus 2, and 1 will be the way that you have that there. So you're showed that k is minus 2, and the common difference is 3. Okay, the other way that you could solve that, which would be more work, but maybe is the more proper way to do it, you'd have k minus minus 5 is equal to 1 minus k. Okay, so remember, the terms minus from each other are equal. So k plus 5 equals 1 minus k. If you plus k to each side and minus 5 from each side, you would have 2k equals minus 4 and k equals minus 2. Then working that out. Okay, either way, you get the same answer. Okay, so that's showing the common difference. Then you're told to find T10. Okay, so I'll just leave that up there. So remember our Tn formula. So Tn equals A plus n minus 1 d. So we've got our A, the first one is minus 5. We've got our d, which is 3. Okay, so we just have to sub in 10. T10 equals A, so minus 5 plus n minus 1. No, not n, we have 10. 10 minus 1 times our difference, which is 3. Okay, so we can work this out nicely now. We've got minus 5 plus 9 by 3, minus 5 plus 27. So 27 minus 5, term 10 is equal to 22. Okay, so that's just subbing into the formula. Okay, and now you're asked to find which term of the sequence has a value of 247. Okay, so for this, the easiest way to find this is to find our Tn formula. Okay, so we'll go Tn equals A plus n minus 1. So we have A, so it's minus 5 plus n minus 1 times our d, which is 3. Okay, so minus 5 plus 3n minus 3, so minus 8 plus 3n. Okay, so we've got a Tn, and we need to find which term has a value of 247. So we need to let this all equal to 247. Okay, so when it asks you which term in a sequence has a value of something, you know that you need to use a linear equation. Okay, nice simple linear equation. We'll add 8 to both sides. Add 8, and then you'll be left with 3n equals 255. And then we're just going to divide by 3 to finish up. And we're left with n equals 85. Okay, so term 85 is the answer to that one there. Okay, there's just one more part left. You're told the first 3 terms of a different arithmetic sequence are 4, 9, and 14. Okay, so already we can see this, 4, 9, 14. You're told it's arithmetic, so that means there's a common difference. So we've got plus 5 to each of these. So A is 4, D is 5. Okay, so we're told to find S50. So we use our S50. It's going to be, so we've got the formula over here. Always write it when you're in an exam. I've got it here, so I'm just going to use it. But always write it when you're in an exam. So n is 50. So that's what that means. N is 50. So we can do 50 over 2. Then 2a, so 2 by 4 plus 50 minus 1, n minus 1 times the difference, which is 5. Okay, so 50 over 2 is 25. 2 by 4 is 8 plus 49 by 5. Wrong bracket. 49 by 5. So that's 25 by 253. And that works out as, so S50 is 6,325. Okay, probably going to need a calculator for that one. So your answer is 6,325. In general, when you're finding S numbers, you're going to have much bigger answers. So 6,000 is quite normal for that. Okay, so I'll just zoom out so you can see all of this 2021 one. Okay, it might be quite small on your screen, but anyway. Okay, so the first one, find the common difference. Second one, find T10, do a linear equation, then sub into Sn. So that actually wasn't a bad question at all. So you can just pause and take a look at that, and I will move on to the next one again. Okay, so I would say I'll make this one the last one that I do, because this video has been going on a right while. So this is a 50-mark question, so this time it's a long answer question. So the first 3 patterns in a sequence of patterns is from 2021, contain dots and crosses are shown below. Okay, draw the 4th pattern. So that's a nice one when you have to draw the 4th one. So you can see there's 1 dot, there's 2 dots, there's 3 dots. So that means the next one's going to have 4. So you're going to have 4 dots. And you see again 1, 2, 3 down here. So you're just going to have 4 down the way instead. Okay, so that's it. That's a nice, easy, probably 5 marks just for doing that correctly. Okay, drawing the 4th pattern. Now, find a formula in n for the number of dots in pattern n of the sequence. Okay, so you can see clearly that you've got 1, and then you've got 2 dots, then you've got 3 dots, and then you have 4 dots. Now, there's an easy way to look at that. If that is T1, T2, T3, T4, you can see very clearly from that n is going to be equal to 1. Or n is going to be equal to none. No, Tn is going to be equal to n. Okay, each time it's just going plus 1 each time. So it's just starting at 1 and going plus 1. So if you did want to just put it in the formula properly, it would be Tn is, remember, a plus n minus 1d. So a will be 1 plus then n minus 1, so that'll be 1 minus, sorry, n minus 1 times the difference, which is 1. So it'd be 1 plus n minus 1, which is just n. So either way, Tn is just going to be equal to n. Okay, so that's the number of dots. Right, oh yeah, and there's the formulas below there. So if you want to do it properly, it's like that, but you could just see it's 1, 2, 3, 4. Okay, moving on up to the next part of the question. Okay, find the total number of dots in the first 20 patterns of the sequence. Okay, so when you see the word total, you need to think Sn. So Sn, remember, I just don't have it here, is n over 2, 2a plus n minus 1d. Okay, that's always, so if you see total, that's what you're looking for. Okay, and here we had our first one for dots was just 1, and our difference was just 1. So a is 1 and d is 1. And first 20, so we're going to have n is 20. So that means just sub in all these numbers. So n over 2, 20 over 2, 2a, so 2 by 1, plus n minus 1 is 1 minus 1, times the difference, which is 1. Sorry, n is 20. 20 minus 1 times 1. Okay, so 20 over 2 is 10. 10 by 2 plus 19 by 1. So it means 10 by 2 plus 19 is 21, which will give you 210. So S20 is going to be equal to 210. So if you add 1 plus 2 plus 3 plus 4, all the way up to 20, you get 210. All right, the table shows the number of crosses for the first two patterns. Complete the table and hence find a formula for the number of crosses in pattern n. Okay, so I will zoom out again just so you can see it. Okay, but I will zoom back in. So we start off with 1, and then we have, this one is a 2 by 2, this one's a 3 by 3, and so on. So we've got 9, we've got 16, then 5 by 5 will be 25, 6 by 6 will be 36. Now, the number of crosses in pattern n, you will notice, 2 by 2, 3 by 3, 4 by 4, all of these things are the squared numbers. So 1 squared, 2 squared, 3 squared, 4 squared. Okay, so whatever pattern it is, it's just it's squared. So our answer here, number of crosses in pattern n, I'll have to just get rid of that, it will be n squared. Okay, so that's just an easy one to look at. It's just n squared, you don't have to do any of the fancy stuff. Okay, so find the number of crosses in pattern 12 of the sequence. Okay, so that just means sub into this. So n squared for 12 will be 12 squared equals 144. Okay, very simple. Just multiply it. And then find the number of shapes in pattern 10. Okay, so the dots is n and the crosses is n squared. Okay, so it's pattern 10, so we're going to have 10 for the dots plus 10 squared of the crosses. So 10 plus 100 is 110 in total. So number of shapes, there's 10 dots and 100 crosses. So those are the crosses, those are the dots. All right, that's a nice easy one there. Now, just to look at the last part of this question, and then that'll do us for today. Okay, a sequence in a pattern of crosses are shown below. The number of crosses in pattern n is Tn, and the general term describing Tn can be written in the form n squared over 2 plus bn plus c, where bc is an element of OR. Okay, so this is where you need to use your simultaneous equations to find what the answer is. Okay, so T1 we can see very clearly is 1 in pattern 1, and T2 there's 3. So this is 1 and 3 here. Okay, we've got to sub these in. You're given it here, so you actually don't have to find out A, but here you can see that this n squared over 2, so that means A must be 2. A is half, because it's n squared over 2. So the second difference must be just 1. Okay, so half the second difference is a half. But anyway, use substitution, T1, yes, okay. So for T1, that means n is equal to 1. So we have 1 squared over 2 plus b times 1 plus C is all equal to 1. Okay, so that means a half plus B plus C equals 1. And if we minus a half from each side here, we get our formula here as B plus C equals a half. Okay, so that's one formula. Now you do the exact same with the other, except we've got 2 squared over 2. So this time n is 2, n equals 2, plus b times 2 plus c equals 3. Okay, so 2 squared is 4 over 2, which gives you 2, plus 2b plus c equals 3. And when we minus 2 from each side here, we will get 2b plus c equals 1. All right, now that we've substituted those two in, we can use simultaneous equations to work this out. Okay, so the easiest thing is to put the one with the 2 at the top. So we're going to put 2b plus c equals 1 at the top. And at the bottom, we'll just put b plus c. And instead of a half, I'll just put 0.5 because it'll just be easier to calculate. Now, we can see that these c's are matching up. So we can simply just minus this off. So we can change the signs. That'll be minus, minus, and minus. So that means 2b minus b leaves you with just 1b. C minus c will cancel out. 1 minus 0.5 is going to be 0.5. Okay, so we're left with b is 0.5, and now we can just put b plus c, and we can sub back in. We can put 0.5, so that's our b. 0.5 plus c equals 0.5. Now, very clearly, when you minus 0.5 from each side here, you'll be left with c equals 0. Okay, so we've got b equals 0.5, c equals 0. Okay, now it doesn't actually tell you to do this, but I will just do it. So our final formula is n squared over 2. That doesn't change. So Tn equals n squared over 2, then plus Bn, so 0.5 or a half. Okay, n squared over 2 plus a half n, or an easier way to write that would just be n over 2. And c is equal to 0, so that's it. Okay, so there's quite a lot of work in that where you have to do the subbing in thing up here and then a simultaneous equation down here. So that's probably the hardest thing in patterns for Leaving Cert Ordinary Level. And obviously all of this is relevant to Junior Cert as well, and at Leaving Cert Higher Level. It's just more advanced there. Okay, so I'll just zoom in on this just so you can get a view of the whole thing that I've done there. Okay, and that will do us. This is as long as a video as I've made, but I've gone through a lot of exam questions there, so hopefully in some sense that has been useful to you. Okay.